We're going to start with Chapter 8, Section 1, and Section 2. And this is dealing with quadratics and graphing them more importantly. So let's kind of jump right into this. There's a couple different ways that we can do this. One of them would be getting the vertex and then using the table, which is probably the most effective way. So when we look at something given to us, so in this case we have g of x equals x squared plus 5. What we need to take into consideration is that anything that's got the x squared is going to be the x value of the vertex. Anything tagged on behind it is going to be your y value. Now, x squared we said equal to 0, and the square root of 0 is 0. So we know x equals 0. The y value is whatever it is. If it says plus 5, then it's just positive 5. So that means my vertex is going to be 0, 5. So when I graph this, we're going to know we go up 1, 2, 3, 4, 5, and we put our dot. Now, we know a couple things about this equation, which is something that hopefully you will take away. One of them is it's going up, and we know it's going up because the x squared value is positive. There is no numerical coefficient on the front making it become a negative, so therefore it's going to stay going upward. So to graph this, like I said, the easy way to do this is just to do the table. So what I usually do is do 5 points. I put the vertex in the middle, and I go 2 below and 2 above. So 2 below 0 is -1 and -2, and 2 above 0 is 1 and 2. So let's put those in for the value of x. So -1 squared is 1. 1 plus 5 is going to give me 6. 1 squared is also still 1, plus 5 is 6. Now, this is not just an anomaly. They are meant to be symmetrical. So that means that when we're graphing these, they're going to be the same. So the first one, if we go up here, we're going to go right 1 and up 1 more for 6. Left 1, up 1 more makes it 6. So as you can see, we're starting to build our parabola. Now, the next one is going to be in -2. So -2 squared is 4. 4 plus 5 makes 9. 2 squared is 4. 4 plus 5 is 9. So in this case, if I go over 2, I'm going to go up to 9. So that's 6, 7, 8, 9. So I'm going to be over here and back 1 and up the same. So this here is our little parabola. Now this is a good example of a normal growth of a parabola. There is nothing on the front of the x squared. So therefore it grows the same. We're used to seeing it start at the origin, and in this case we went up 5 because the y value told us to go up 5. So let's look at another one. Let's look at number 2. So m of x equals x squared minus 3. So if you look at the first one versus the second one, the x squared is going to stay the same. So we know we're still going to have 0 for our vertex for the x part. So I'm going to have 0. And then the y value is going to be -3. So the difference between the first one and this one is going to be real simple. Instead of going up from the origin, we're going to go down. So I'm going to go down 3 and put my dot. Now, see how it's positive here? So I know this time I am going to go up and I'm going to cross the x-axis. The last one was denied that opportunity because it was hovering above the x-axis to begin with. In this one, we are below the x-axis and opening upward, so therefore we're going to cross it. So let's take and do our table. 0, -3. So we're going to have -1, -2, 1, and 2. And it's going to behave similar to the first one. So the y values on the 1 above and 1 below are going to be the same, and the 2 above and 2 below are also going to be the same. So if I put in 1 squared, I'm going to get 1 minus 3, which is negative 2. And the same thing's going to happen here. If I put in 2 squared, I'm going to end up getting 4 minus 3, which is going to end up being 1. So when I graph this, it's going to be positive 1 and negative 2, and negative 1 and negative 2. The next one is going to be over 2 and up 1. So back 2 and up 1. So once again, the parabola behaves the same. And you can add extra points if you'd like, but usually 5 gives you a good idea of how it's going to grow. So that one right there is number 2. Let's look at number 3 and 4, because those are something a little special. Now we're getting into some changes. So for number 3, I have n of x equals negative 3x squared minus 2. So the vertex is still going to be the same. So the vertex is going to still be 0 for x, because negative 3x squared equal to 0. Well, I divide a negative 3 into 0, it's still 0. And then when you square root 0, it is still 0. The y value is negative 2. So I know when I begin my table, this is going to be my starting point. So I know I'm going to have 0, negative 2. So negative 1, negative 2, 1, and 2. Right here is my vertex point. Now put 1 in. So 1 squared is 1. 1 times negative 3 is negative 3, and negative 2 makes negative 5. So it's going to be negative 5 this time. And if you notice, that means we are going to go down. So you're probably wondering, why would we go down? Well, because look at the number in front of your x squared. It is negative, so therefore the whole thing is going to go down or open up down. So there's 2, 4, 5, and back 1, and over 1. You're going to notice some changes with this also. So let's just keep going. So 2 squared is 4. So 4 times negative 3 is negative 12. So I'm going to have negative 14. So this is going to grow fast, and we're going to kind of come off the graph a little bit. So if I go over 2, that's 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So basically it'd fall down here and right there. So it would look like this. And yeah, I just fell into the other graph, but it's given us the outcome we're needing. So if you look at this, what do you notice this time about it? If you look up here and compare it to this one versus this one, yeah, this one is going up, so I'm not talking about the up thing, but look at the way it's built. Do you notice that it's narrower? So if you have a whole number, no matter if it's positive or negative, on the front of the x squared, you're going to be narrower than the original. So what's going to happen with 4? Well, let's dive in. So q of x equals 1/2 x squared minus 4. So once again, our vertex is going to be 0 for x, because half of 0 is still 0 when you divide it. And then when you square root 0, you get 0. So my y value is negative 4. So when I graph this, I am at 0 and negative 4. And we're going to go up this time again because the half is positive. So what does that half do that's going to make this a game changer? Well, let's put in some points and see if we can find something. So 0 and negative 4. I'm going to try to stick with even numbers because of cutting it in half. It's easier to cut halves once they're even. So I'm going to do negative 2 and negative 4, which is going to give me 2 and 4 down here. So let's do this. I have negative 2 squared, which is going to make it positive 4. Half of 4 is 2. So 2 minus 4 is negative 2. And I'm going to have negative 2 here. So if I'm over here at 2, I'm going to be down 2. Back here at 2, I'm going to be down 2. Now let's do the 4. So 4 squared is 16. 16 cut in half is 8. 8 minus 4 is 4. So if I go over here, there's 3, 4, and I'm going to go up 4. Same thing, if I'm back 4, 3, 4, and up 4. So what do you notice about this one compared to the other two? What do we notice? Well, compared to the last one, this one's a lot wider. But compared to the one above it, it is also wider. So what we need to store in the back of our mind is, if it has a fraction on the front of our x squared, then that's going to tell me that it's going to be a wider parabola. Now keep in mind that the positive thing is still going to tell me if it goes up or down, but the fraction itself is going to tell me that it's going to grow slower, so it's going to take longer. It's going to open up wider. Where if it has a whole number on the front, then it's going to grow faster and it's going to be narrower. It's like being stretched. Okay, so that's the first 4. So let's look at zero factor functions. So this first part is straightforward. The second part, we're going to see whether or not they have any type of value. So let me take this off the graphing paper here and put this into some plain paper. So in this case, it says find the zeros of the function, and I have y equals negative x squared plus 1. Okay, you may not realize this, but the best way to do this one is going to be take and factor it. You can factor this. If you pull out a negative 1, this becomes x squared minus 1, and this breaks into 2 groupings. So I'm going to have x plus 1 and x minus 1. So we're getting into the difference of squares. I set each grouping equal to 0, so x equals negative 1 and 1. So that's where it crosses the x-axis. Same thing for number 6. Y equals negative 4x squared plus 16. Well, I'm going to factor out a negative 4, and this gives me x squared minus 4. Well, when we set that equal to 0, I'm going to end up with, well, the square root of 4 is 2, and half of x squared is x. So x plus 2 and x minus 2. Now, you're going to notice that I've been ignoring these numbers in the front. Those do not have a variable attached, so therefore I do not need to do anything with them, because 0 equals negative 4 is a false statement. So it just drops out. So you set each one of these equal, it's going to be negative 2 and positive 2. So try number 7. So pause it and try number 7. When you unpause it, we will go through it. Okay, I hope you paused that. Now, when you go through this, you're probably thinking, well, that was unfair, Ms. Kaufman. You didn't give us a y this time. You gave us m of x. Remember, it is the same thing. M of x is the same as saying y. So if it makes you feel better, do that. We're going to pull out a negative 1, which is going to give me x squared minus 64. Now, we're going to set this equal to 0. So I have negative 1, parenthesis, x plus 8, and x minus 8. So x is going to be equaling negative 8 and 8. And then last but not least is number 8. Once again, go ahead and pause the video, work this one out, and then you can restart it. So for this particular problem, hopefully you've taken a moment to pause it. We're going to do the same thing. It's the same as saying y. We're going to pull out a negative 1, which gives me 9x squared minus 1. So this is actually 3x minus, or plus 1 and 3x minus 1. So you set these equal to 0, your x is going to end up equaling negative 1/3 and positive 1/3. So when I ask you to find the zeros of the function, that means where do I cross the x-axis? All right, not the vertex, but the x-axis. And yes, you're thinking, well, I could have done that if I was graphing. That's true. That's true. You probably could have. All of these worked out, but it does not always work out. First thing you need to realize is occasionally you'll have a prime. Remember, prime means that you can't factor it, period. If you have that, that means that you are hovering above or below the x-axis and not going to be crossing the x-axis. They have a few of those. So let's look at this here. Number 9, it says a parabola opens down and the vertex is 0, 5. It says sketch the parabola with the given characteristics. So let's use the same paper we were using a moment ago. Put that back up here. So let's look at number 9 and 10. So for this one, the parabola opens down and the vertex is 0, 5. So I go up and give my vertex. So 1, 2, 3, 4, 5. And it says it's opening down. So it's kind of going down like this. Remember, it says sketch it. So we're not looking for anything there. So that is the maximum point, by the way. The max point is when the point of the vertex is the highest in the sketch. Number 10 talks about the parabola opening down. It says the lowest point. So that means that when I come up here, there it is 0, 4. This is going up, and I know it because it says that it is the lowest point. So if that's the min or lowest point, then we're opening up. Max or highest point, I'm opening down. All right, so let's just kind of give you an idea there. The last one that we want to look at is the story problem for number 11. And a lot of times I get asked, well, how do we know what this is really going to be used for? Well, here's how we use it. Look at number 11 here. So for number 11, it says the function f of x equals negative 16t squared plus s to the 0. So these have meaning. This negative 16t squared actually is gravity. And the height in feet of a falling object, t, stands for my time. The initial height means where you originally start from is going to be in front. So that's what your S0 is going to be. So a tennis ball falls from a height of 400 feet. After how many seconds does a tennis ball hit the ground? So in this case, I am saying negative 16t squared plus 400t, because they say s, but it's t that we're going to put in terms of. Let's see if 400 is divisible by 16. If not, we're going to take out an 8 for sure. So 400 divided by 16, we're in luck, it's 25. So we're going to take out a negative 16t, and we're going to have t minus 25. And it's wanting time. So if I set each one of these equal to 0, negative 16t equals 0, therefore t is going to equal 0. And that makes sense. And we set the t minus 25 equal to 0, therefore that one is going to make sense also. So if I'm at 20 or 400 feet, folks, that means that we are pulling this out. And you want to do that. Now, what they're doing is, I take this back. The t shouldn't be there. But when we set this equal to this, you're still going to have 0. And 400 feet is how hard you're hitting it. So that's t squared. So what is the square root of 25? Well, that's going to be 5. So negative 5 and positive 5. Now, if you're wondering what that means, we can't have a negative time, because negative time means that it hasn't happened yet. So it took 5 seconds from the ground to the 400 feet, and then from the 400 feet down. So think of it this way. Pretend right here is 400 feet. I'm saying it took 5. 1, 2, 3, 4, 5 seconds. 1, 2, 3, 4, 5. 5 seconds for it to reach. I should have been over here. Sorry about that. So what I'm saying is, if I hit it and here's 400, it took 5 seconds for it to go down and hit the x-axis, or the ground in this case. So that's really what it's trying to get across. And then it says, suppose the initial height was decreased by 384 feet. Well, it's easy. 400 minus 384 means it's just going to be 16. So it means that it's only going to be 16 feet. So that means negative 16t squared plus 16. This is the part B. So pull out a negative 16, and you're going to get t squared minus 1. Well, that means t equals negative 1 and positive 1. Once again, let me use a different color to put it on the same graph. In this case, we are going to have it being at 400, or actually 16 feet. So it's going to be down here, but it's going to be 1 and 1. Well, we know that this is going to be the one that we're looking at because the negative is not the one that we're looking for. So this right here is the part B, is the smaller one. We're only at 16 feet above the ground. Okay, this is the end of the video. If you have any questions, email me and we will get it taken care of.